So you should notice in your notes, there's a formula up here for exponential growth, and then there's a formula in the middle for exponential decay. Bless you. The two formulas look exactly the same, except one has an addition sign and one has a subtraction sign. Okay, which should make sense, right? Because growth is going up and decay is going down. Okay, so our formula is y equals, which will always be there, A is going to be replaced with our starting value.
Yeah.
Okay, so when we look at the story problem, whatever our starting value is, that's going to be A. And then R is going to be replaced with whatever the percent of change is. Okay, but that percent is going to have to be in decimal form. So if we can look at a problem and we can identify those two things, we literally after that point are just plugging and chugging.
Let's plug and chug again.
Like, just make the table and put the numbers into a calculator.
Oh.
You don't have to actually
So like what we do is
solve something after that.
oh,
It was just like what we were just doing in the POD and what we did on Wednesday. Okay, so let's say Jose opens a bank account and puts in $1,200. It earns 4% interest each month. Now, I'm going to tell you right now that earning 4% interest each month on $1,200 is not realistic. However, with most things in life, money makes money.
That's true.
Okay, so if you invest, if you put it into an account that is interest earning, okay, you will actually get money earned off of your money. So like people who have millions of dollars don't have to work because they can invest their millions of dollars and live off of the interest that it makes. It's, right, we can all have feelings about how that much money exists in this world for people, but that just is what it is.
That's a lot of truth.
Okay? There is also some things to be said at all levels of making decisions based on how it exponentially grows. And we're going to talk about that on Monday, which will actually pertain to things that you want to think about in terms of what types of raises to take or things like that if you're looking in the future, okay? So I'm picking this sort of larger number just so you can see a little bit more of a drastic picture so you can carry that idea over into Monday. Okay, so it's not realistic this percent, but it is still a true thing that happens. So the first thing it says is to write an equation to represent this information. So if we want to write an equation to represent this information, we are going back to this basic formula. And we are going to write down y equals, except now instead of A, we are going to fill that in with the starting value. So in the situation of Jose opening a bank account and putting in $1,200 that earns 4% interest each month, how much did he start with?
Or $1,200.
$1,200. So A is now going to be the $1,200. Okay, so I replaced A with 1,200. I'm now going to put a parenthesis. 1 plus.
Isn't it
4.
0?
Okay, but now I need my rate to be a decimal. So you have one of two choices. You can either A, know that with 4% you move the decimal point 2 places to the left, or in your calculator there's a percent button above the open parenthesis. So if you type in your calculator 4, second, open parentheses, and then hit equals, it will give it to you as a decimal. And we should see 0.04.
yeah, that's what I said.
Now this absolutely is the correct equation, but most likely we wouldn't see this as an option, especially if it was multiple choice, because it's easier to simplify this into y equals 1,200 times 1.04 to the x, right? I just added these two things together. And since 1 plus 0.04 is super basic addition, right, it'll just save us from retyping that over and over again later. Any questions on where that equation came from?
No.
It then says, make a table to represent the amount in the account for the first 5 months. So if we want to make a table to represent month 1, 2, 3, 4, 5, we are doing exactly what we just did in that bell work with graphing an exponential. So we will pick up our calculator, and in our calculator we will put 1, 2, 0, 0, open parenthesis, 1.04, close parenthesis, up caret 1.
1,240.
And we get 1248, which means if we just let that money sit for a month, we've earned $48. And then we're going to change that 1 into a 2.
1,297.92.
And then we're going to put in a 3.
1349. Point.
I guess if we round, even though the bank wouldn't really be generous a round up for you, but we'll just use math rounding rules. That's us. We'll finish after lunch. What?
That's lunch?
What the heck? I'm not ready.
Okay, so here's our table complete. What does that mean?
I don't know.
That's
means-
within the first 5 months.
That's
So after 5 months, how much money do you now have in your bank account?
1,400.
$1,459.98. So if you put $1,200 into your account, you don't touch it, you don't add money, you don't withdraw money, you end up with an extra $259.98. Right? This is how people with money make money. Right? If you have $1 million and you just live off the investments, you can just make $55,000 a year doing nothing. Okay? Guys, notes, computers away, headphones away, like we are back in class. So if we want to know how much Jose would have in 3 years, what would we need to do?
Wouldn't you multiply?
Well, there's 12
What? 12 times 3.
Right, so this 36 months is because this was all based on months. So we have to make sure whatever value we're plugging in is based on that same time frame. Okay, so we'll take that same equation, but now we'll plug in 36. This is always a shocking number to my students.
Holy heck.
Why don't you just ask Jose? Like,
Okay, so according to this model, Jose puts $1,200 into an account, doesn't touch it, doesn't add, doesn't subtract. After 3 years, he's now going to have almost $5,000. Yes, Bailey?
Where would we put that in the equation?
We are always plugging that in for the x. So this value right here is what's always getting replaced.
Okay.
Okay, so I replaced it with a 1, I replaced it with a 2, now I'm replacing it with a 36.
Okay.
Okay, and while a 4% monthly interest rate on a bank account isn't realistic, there are things that there are. So do any of you know, like, have your parents set up like any type of like college savings account or like any bonds? Do any of you have like the paper things?
yeah.
Anything like that? So there are ways that like basically show, here, you have this money, you can't touch this money, you don't have access to this money until so many years have passed. But then once all these years have passed, you put in $1,000, but if you wait 10 years, we'll then give you $8,000 back.
Isn't that a CD?
Man,
Right, so there's lots of different things that you can get.
they set mine up wrong.
Okay,
Like,
so
you
there are
put $1
types of
billion
investments,
in
there are
you
types
get
of different,
$3 billion back.
so people who have like billions of dollars, right, when we're talking about the
Bill
wealthiest people in the world,
Okay.
right, they can invest their money into ways that then give them money back, and they just can live off those earnings.
I'll just put like
I unfortunately do not have that ability because I have bills to pay every month, which uses all of my money. But
honey.
there are still ways. So lots of times you'll hear people say that they set up these college funds young for kids because if they set them up and they just add a little bit of money to it over time, that money starts to grow and it is a lot of money by the time you're ready to go to college.
A lot of money.
It is a lot more than it started with. Yeah, because exponential growth happens really fast. Okay? So, any questions on this one?
No.
Then let's look at our next one, which is exponential decay.
Oh.
So exponential decay is the exact same idea. The formula is exactly the same, except instead of having an addition sign here, it is replaced with a subtraction sign. And again, it's because the values are getting smaller. Right? So if I say, I'm going to go buy a car. Okay, I'm buying a new car. I go to the car lot. I buy the car. If I tell you what type of car I really want, you'll all laugh at me.
What is it?
Minivan.
Rover.
It is not a Subaru.
What is it?
It's worse than that.
What is it?
A Bumblebee.
A
Honda.
Right now, no, I had a Mini Cooper before.
Oh.
A
The
Prius.
car that I really want is a Buick Cross Tour, which is a station wagon.
What does that mean?
I really want this station wagon.
What is it? Can you show me a picture? It's like a minivan.
No, it's not a minivan, it's a station wagon.
Yeah, it's a station wagon.
I will show you very quickly, so then you'll know.
Is it like new or is it an old car?
It's new.
You took a picture with another girl.
Kanye West.
Stop.
It's okay, Chase.
False accusations.
I saw it.
Okay, so here's what I want.
Oh, I mean that's not bad.
It's a station wagon.
That's nice.
What's the station?
It's like $100,000.
It's like a long,
It's like a
small car.
It's like a.
I want a station wagon for Midna. That's why I want a station wagon.
It's like a pretty
Or
car
just
for
get
mom.
Vigna's own sled and just strap it to the back.
I just
of your
want
car.
Midna to be able to jump in easily, and then there's a big sunroof that goes all the way back. Okay, so anyways, I'm fine. I'm going to buy my new station wagon, whatever. I buy it. I start driving it. What happens to the value of the car?
It
It
goes
goes
down.
It goes down. Okay, it starts depreciating is the word that we use there.
How much money is a station wagon?
Okay?
Like
Haley.
$100,000.
Okay, so it's going down in price. It's decreasing. That's exponential decay. If we say, okay, it's decreasing in price by 1% every year or whatever. Okay, now there are other ways that exponential decay happen. It happens in science with different types of chemicals. You know, carbon dating. Have you heard about that? How like when we dig up fossils, we can tell how old something is. Okay, the way that we do that is by looking to see how much carbon is left in the bone. Okay, because we know what rate it decays at. And we can see what's left and then we can then determine. Okay, so this is the same idea, but now the numbers are going down. Right? The price of a car, a chemical that's decreasing. This situation is going to be a tournament. Okay, so each year the local country club sponsors a tennis tournament. Play starts with 128 participants, and each round half of the players are eliminated. How many players remain after 5 rounds? Okay, so first thing we are going to do is we're going to write an equation that represents this information. So we are going to say y equals, and we're going to stick to this format. So y equals A. What does A represent?
128.
And how do we know that it's 128?
Because it's the first thing.
It's the starting value, right? A is always the starting value. What did we start with? We started with 128 participants.
And then.
Okay, so as each round goes on, is there more players or less players?
Less.
Less. So we know we want to do 1 minus. Okay, so I'm doing 1 minus.
Is it 5?
Okay, now here's a problem because we don't see a percent in here, do we?
No.
So we have to use our brains a little bit. Right here it says each round, half of the players.
So 50%.
How do we represent half as a percent? 50%, which is then
Oh, that's like this.
0.5, right? Because it has to be in decimal form. So 0.5 is the one we want to plug in. That 0.5 is coming from 50%. Okay, so we want 1 minus 0.5. Okay, now just like we said before, right, we'll then simplify this. So 1 minus 0.5 is what?
0.5.
0.5. So now we can make a table and start calculating each round. Okay, so after 1 round, after 5 rounds is what it says. So after 1 round,
64.
we'll put into our calculator, right? We'll type in the equation just like we see it. So we'll say 128 parenthesis 0.5 up carry 1. It'll be 64. Then we'll put in 2.
32.
Then we'll put in 3.
16.
Do these values make sense that we're getting out?
It's half every time.
It's half every time. Half of 64 is 32. Half of 32 is 16. Half of 16 is 8.
Yeah.
Right? So those values should be making sense.
Yeah.
So how many players would there be after 5 rounds?
4.
4.
2.
Wait, what's my total?
Yes.
I didn't get C on the first try.
Like you just need me to flip back?
It's 4,900.
Here, I'll just flip back to it.
Maybe I should say that.